My name is Rohan Tyagi, and today we are going to solve this CSES problem set counting towers. And this is a dynamic programming algorithm problem, and we are going to solve this problem using dynamic programming with a bottom-up approach. What we are going to do in this problem is we are going to solve the problem for n equals to 1, then for n equals to 2, and it would solve all the possible solutions for n equals to k by using the values of n equals to k minus 1, k minus 2, and so on. So I would be using basically two vectors in this particular problem. One for the values, different values, and the different possible solutions for every values of n, and another is the sum vector, which would be holding the value, the summation of all the previous values. So suppose the solutions are stored in a vector called dp, and if dp of 1 represents the number of possible solutions for n equals to 1, and dp of 2 represents the number of possible solutions for n equals to 2, the sum 1 represents all the possible solutions for n equals to 1 and below n equals to 1, and sum of 2 represents the sum of all the values of dp0, dp1, and dp2. In the similar manner, sum of n would represent the summation of all the values of dp up to n. So sum of n would be equals to dp of n plus dp of n minus 1 plus dp of n minus 2 up to dp of 0. So I would be using these two vectors, and you would later see in the solution why I am using the values of summation in this particular problem. So let's head to the problem solution. Okay, so I have used this dp vector for storing the values of the solution, another vector called sum for my computation. This is the number of test cases, and inserting the value of taking input the value of n, dp of 0 equals to 0, dp of 1 equals to 2, as we can use two choices. Either we can use two independent boxes, or we can merge two boxes to use a rectangle. So these are the two choices we have. As dp of 0 equals to 0, the sum of 0 equals to 0, the sum of 1 equals to 2, the sum of 2 would be sum of dp of 2 plus dp of 1 plus dp of 0. Hence I have used for int I equals to large. Large is initialized as 2, so I would be 2, I less than equals to n, I plus plus, dp of I is equals to dp of I minus 1 multiplied by 2. Basically what I have done here is I have used I have brought the solution in many different parts. So suppose there are horizontal lines between your final layer and the previous layer. So all the solutions of the previous layer are stored in dpi minus 1, and the possible solutions for the new layer can be either both the boxes can be merged, or both the boxes can be independent. So we have two possible solutions. We can multiply 2 with the previous solution, and we can get this value dp of I minus 1 mod and 2. And now moving forward, suppose there are no horizontal line with the new layer. So now we would have two choices: either we have the vertical line or we don't have the vertical line in our new layer. So if we don't have the vertical line, this problem solves this particular syntax solves the problem. It would compute all the values which don't have the vertical lines in the previous problem in the topmost layer. Okay, let me give you simply the idea. In the problem in the previous solutions, there may be some solutions in which the topmost layer may not have the vertical line, and all we need to calculate all those solutions, because if we are going to add our new layer, and which doesn't have the vertical line, we can't add that boxes which have vertical line to the boxes which don't have the vertical line. So we need to calculate the number of boxes or the number of possible solutions in the previous problem, in the previous solution, uh, which do not have the vertical line in their topmost layer. So these are the number of solutions for that problem. Now we have three choices. If we have the far we have solved the problems which do not have the vertical line in the new layer. Now if we have the vertical line, what we can do here is we can we can subtract all those solutions in which we have the vertical line from the from the total solution, which is dpi minus 1 minus this solution. So on subtracting this value from dpi minus 1, we get all the solutions which are having the vertical line, and we will multiply this with 3. We have multiplied this 3 because when we have the vertical line in our new layer, uh, what we can do, we can have is we can have a box in the left or a box in the right, and no box in left or right, both are open from the bottom. So we have added all the solutions. Now we have computed the value of sum, and change the value of large, and dp of n will give us the solution. And that's it. Thank you. If you like my video, if you like the solution I have gave you, please like my video. And this is my first video. Your feedback would be highly motivating. Thank you.